By way of introduction, my name is Ross Dixon. I'm a Senior Manager at RSM Australia in our Albury office. I'd like to welcome you to the second in a series of webinars focused on manufacturing and the various challenges which manufacturing businesses are currently facing. It's great to see so many of our clients and some new faces here today, and we're hoping to return to some in-person events in early 2022. In terms of RSM is an accounting and consulting firm with 30 offices across Australia. Here at RSM, we're dedicated to building and supporting capability in the manufacturing sector and currently work with a number of clients supporting them on their manufacturing journey through things such as structuring tax, R&D tax incentives, as well as those traditional suite of accounting services. The last few years has seen obviously a resurgence in Australian manufacturing, with the Australian-made tag becoming a moniker for quality, ethically sourced products. Increasingly, however, there's been a focus on how to drive organic and scalable growth, and one of the tools for that is automation, innovation, and robotics. I'm pleased to introduce our four speakers today, which is Dr. Sue Key, Dr. Phil Cummins, Simon Dawson, and Jessica Olivia, who is the National Head of Manufacturing here at RSM. Before we start, just a few quick housekeeping rules. This webinar is going to be recorded and will be made available to all participants. You'll get an email around that. There'll be a panel discussion at the end of the presentation, so please enter those questions in the Q&A box at the bottom of your screen. All participants will be muted, and basically, once you've finished the webinar, please feel free to get in touch with either myself or Jess from an RSM perspective, or feel free to reach out to the speakers individually. And on that, I'd like to introduce our first speaker, Dr. Sue Key, who is the CEO of the Queensland AI Hub. Sue is following a role as the Research Director for Cyber Physical Systems at CSIRO's Data 61. She led the development of Australia's first robotics roadmap, outlining how robotics and automation will impact on every sector of the Australian economy. Sue has spent more than 10 years in the manufacturing sector, working with CAST, and was formerly the Chief Operating Officer for the Australian Centre for Robotics Vision. On that note, I'd like to introduce Sue. Thank you.
Thank you, Ross. So today I'm going to talk about current trends in artificial intelligence and robotics and how these are applied to manufacturing. So there are many different definitions of artificial intelligence. The way that I like to think of artificial intelligence is as a way that machines make decisions and take actions that make sense to us as humans, to the point where we trust the machines to make those decisions on our behalf. Australia actually has a great heritage of developing artificial intelligence for many different sectors, and some examples are shown behind me. There are a large number of artificial intelligence companies operating in Australia, developing solutions across all of these sectors, including manufacturing. So the Queensland AI Hub really exists to help build Australia's sovereign capability in artificial intelligence. And we're doing that by pulling together all of the different elements of the AI ecosystem in not just Queensland, but across Australia. So if you're a manufacturer who is looking for an AI solution, please get in touch and we'll see if we can match you with some of the local AI capability in your region. In Australia, according to work by the Queensland Government, the sectors that are most applying artificial intelligence are defence, mining and energy, agriculture, forestry and fisheries, and manufacturing, as well as healthcare and transport. You might notice that our financial services sector isn't listed, but arguably it is the most advanced in implementation of some forms of artificial intelligence. But the data that I'm showing you is actually from questions that were given to artificial intelligence companies. And what tends to happen in the financial services sector, such as the banks, is that they tend to do all of their artificial intelligence in-house. So they're not sourcing that from outside AI companies. But the good news for manufacturers is that you don't need to do that, that there are quite a lot of AI companies probably in your local region who would be able to help provide AI solutions. And there are several reasons that, all of these different sectors are applying artificial intelligence. Artificial intelligence systems can detect patterns in enormous volumes of data and help to model complex interdependent systems to improve decision-making and also cost efficiency. It can help utilise equipment and processes more efficiently and can be used to help address labour shortages by automating some tasks. AI can also be used to make the workplace safer by being able to identify and predict potential hazards. But there are definitely some barriers and challenges to the adoption of artificial intelligence. Building and maintaining an AI system can be a costly investment, and it requires investments in adapting the technology to business processes and available skills, and it may not deliver immediate benefits and productivity gains. There are reputational and legal risks. Harnessing all of the data that you have to get the benefit of AI can also increase exposure to data breaches. Another issue can be resistance and whether there are the actual workforce skills to be able to successfully implement AI. So particularly managers within small to medium-sized enterprises need to have a good understanding of what AI can bring to your business and to also be able to convince staff of the benefits. This is very likely going to require the development of new skill sets across the whole business. And one issue for many SMEs is that, that it may not be immediately apparent what data is needed to implement an AI system. So a whole host of background in data governance and learning how to acquire data and what data to keep is going to be necessary for the successful implementation of AI. And many of you are probably familiar with some of these different implementations of AI. One of the most obvious are the development of digital twins. A digital twin is an identical virtual representation of real-world physical objects, such as a piece of machinery or even an entire worksite. It can be used to catalogue properties, dimensions, and components, to predict behaviour under a variety of conditions, and also to aid with manufacture, repair, and replacement. Digital twins can have a major impact in three main areas: to test from the initial design to completed product, and to optimise the processes, and also to predict failures before they occur. Digital twins provide both historical and real-time data that can be linked to smart maintenance systems, which can make remote adjustments without having to go into the field to fix a physical device. And digital twins can capture and analyse data on how products are being used by customers and what changes could or should be made in new product design and manufacturing to improve market penetration and also customer satisfaction. Now I'll give some examples of the application of digital twins. A digital twin starts as a 3D digital model developed through computer-aided design or generative design. Additional layers of data can then be applied to the model, and data from simulation and real-world testing, coupled with manufacturing data and data from parts already in the field, help to flesh out the digital twin. Well, this might appear to be technology that's only accessible by large organisations, and unfortunately in this format you can't see this video, but I'll supply a link so that if you access the webinar later you'll be able to see. But behind me is the start of a fly-through of the Queensland AI Hub, which was done in about 5 minutes by walking around with a laser scanner paired with a GoPro. And so this technology is really becoming very accessible to small to medium-sized enterprises because the collection of the data is becoming far more simpler. So once you have collected that data, you can make a 3D scan of it and convert it into a digital twin. A digital twin can also just be made of particular objects, and this can go beyond a CAD model. It is often the model plus lots of extra data about that component, including simulation data, manufacturing data, and feedback on the product's performance over time. Essentially, any data relating to a product or a part can be folded into its digital twin, which is the power of digital twins. Just to give one example, a local composites manufacturer has found that in its automatic fibre placement process, it's been able to apply AI to improve the accuracy of prediction of defects detected by physics modelling from 35% to 98%, when AI is applied. They've also found artificial intelligence useful to inform how to inject and cook materials. They've seen a 60% improvement in cycle time and performance of product during the curing process by monitoring the temperature profiles using thermocouples and combining this with simple 1D modelling using synthetic data to better control the process. The same company is also using digital twins in additive manufacturing. So they're looking at laser 3D printing of metal parts. And there are a number of complex factors at play that lead to complexities in the form, material properties, and integrity of the metal parts produced by 3D printing. And these are often related to laser power, laser speed, the spot size, pass overlap, powder composition, the melting point and boiling point of different powder constituents, the contaminants. There are lots of different factors that can all lead to increased porosity and potential defects. So this lack of reproducibility in additive manufacturing can limit its application to the development, particularly of critical infrastructure, things like aircraft parts. However, this can largely be overcome by simultaneously applying artificial intelligence. So far, this company has seen improvements in metal defect prediction, which is a far less stable process than fibre placement, and they aim to use this to reduce the number of print failures, to also change the laser positioning during production in response to real-time feedback, and to reduce the number of defects, producing consistent high-quality metal components alongside the composites that they manufacture. So this is just the beginning of this company's AI journey, and they're really experimenting with different techniques, including game playing techniques, to make the technology more accessible for their workforce. And 3D printing is an interesting area that really is making inroads on traditional manufacturing techniques. And the example behind me is a low-cost, high-precision haptic robot arm by Australian company Huntington Dynamics called the Dexter arm. The development of this arm now essentially means that small to medium-sized enterprises can access a very usable robotic arm for less than $10,000. For most of the industrial robot arms that people would be familiar with, they're usually in the price range of $1 or $2 million. This robot arm is not as big and doesn't have the same capabilities, but you can probably see that by being able to 3D print a lot of the components now, we're really starting to see the point where a lot of robotic technologies are essentially becoming democratized and they're much more accessible to other people. Huntington was recently taken over by the AI-equipped industrial robot company Asara, but the continuing drop in the price of these technologies means they're becoming increasingly affordable and will help support the move away from static robotic systems to much more dynamic solutions. Now, I wanted to give an example of some of the different AI technologies that are being developed right here in Australia that might be of use to different manufacturers. One example of this is the Movis Fit Machine, which is essentially a Fitbit for machine. So it's the little orange circle on the side of the machine here. What it does, it's essentially it detects vibration and it applies artificial intelligence to this vibration monitoring as well as other sensors to predict equipment failure. And this allows early preventative maintenance and avoids holdups on the production line, which can save a lot of money. So as these emerging technologies like artificial intelligence and robotics are becoming more readily available, there are proactive actions that manufacturing businesses can take to help be an early adopter and get the benefits of these technologies. The first is undertaking some serious workforce planning and mapping out the skills required for the future of the business, and then enacting plans to reskill the existing workforce to take advantage of the opportunities presented by these technologies. Because without the buy-in of your current workforce, then the successful implementation of these technologies is very unlikely. It's also important when considering what your future workforce might look like to consider tasks rather than jobs. So what AI and robotic technologies are really good at is augmenting humans rather than replacing them. So they tend to be good at specific tasks, which will free up your workforce to do more value-adding high-level tasks as part of their jobs. Running businesses in the future is going to require a new type of leadership thinking. And as you skill up your workforce to adapt to the pace of technological change, you will need to consider new business models to take advantage of the new applications that come about as the result of using these technologies. Finally, I think one of the big advantages of these technologies is that you will be able to rapidly respond to customer feedback and enact truly lean manufacturing, adjusting production on the fly to meet customer demands. I think it's an exciting future when you embrace artificial intelligence and robotics and the opportunities that they present. And yes, as I mentioned before, the Queensland AI Hub exists to help form connections between the people in Australia who are creating AI with the people in Australia who want to adopt AI solutions. So very happy to be working with RSM, and I know that they can give a lot of good advice in this area, but Queensland AI Hub would also be happy to support any manufacturers on their journey towards adoption of artificial intelligence technologies. Thank you.
Thanks, Sue. That was great. I appreciate your time, and we'll do some questions at the end if that's okay. So our next speaker is Dr. Phil Cummins, who's the acting director of the Facility of Intelligent Fabrication from the University of Wollongong. The Facility of Intelligent Fabrication actually presented at one of our events last year, which was well received in Albury, and actually went on to do some site visits. Phil is the acting director. The FIF specialises in translational research for robotic welding and affiliated advanced manufacturing technology through industry relevant research and development. Phil has 15 years experience in advanced manufacturing research and is passionate about bringing Australian industry into the digital era by leveraging and making sense of the latest Industry 4.0 technologies. So I'll pass it on to Phil.
All right, thanks Ross for that. Yeah, hi everyone. It's my pleasure to be talking with you today about making sense of Industry 4, particularly with robotic fabrication and how translational research can assist. So you've probably seen this infographic before, and since industrialization in the 18th century, we've really experienced 4 industrial revolutions, and each have had their own impact on society. So what's Industry 4 and how does robotics fit in that? Well, let's have a quick look at what the first 3 are as well. So Industry 1 was really about steam engines and mechanizations. And then fast forward 100 years and you've sort of brought the second industrial revolution, which was about mass production lines, which were made famous by, of course, the Model T Ford. And that enabled faster transport, faster communications and that sort of thing. After the 2 world wars and into the 1970s, we had the technological developments, which gave rise to digital revolution, which brought in the introduction of computers and the ever-advancing communication technologies, which is really where robotics, PCs, mobile phones, and that sort of thing came in. So the 4th industrial revolution is about new forms of human-machine interaction through digital connectivity, using technologies like augmented reality and virtual reality, robotics, 3D printing, rising data volumes, increasing power, and that sort of thing. So you've likely seen this graph and you said, well, yep, okay, I comprehend all of that, but don't really understand what it really means for me in my fab shop, my manufacturing center. And also, where do you think your business sort of fits within that scale? Interestingly, most manufacturers are still operating in Industry 4, Industry 2 and Industry 3 area. Most would sort of say maybe a 2.5 or something like that. So Industry 4 can really be visualized like this graph here, where it's not just one digital technology working in isolation, but it's multiple working together in connected ways. In isolation, most of them are actually Industry 3 tech, such as robotics and simulation. However, it's when these digital solutions begin to work together that they add more than the sum of their parts. Does it actually become Industry 4 and quite a disruptive solution? So in a recent study, 200 business leaders took part in an Industry 4 benchmark survey which gave some interesting results. So when it came to awareness, just 44% responded saying that they had a good or better understanding of Industry 4. A similar trend continues with the readiness of the business, with just 46% saying that they felt prepared for digital changes. Some common themes as to why they're not feeling confident to deal with Industry 4 are actually around lack of understanding, lack of skills in the workforce, legacy technology that they have, and a lack of a focused strategic plan. So when made aware of the technologies associated with Industry 4, these business leaders perceive that they would have actually a sizable impact on their business within the next 5 years. So there is a level of expectation that there is real benefit and impact when Industry 4 technologies are adopted. So this graph here shows adoption is slow. Most adoption rates are around the 2 out of the 5 mark, which corresponds to the technology that hasn't yet been adopted, but there is an ongoing discussion and some vision of how it could be play a role. There is one standout though, which is on cloud computing, and which relates to a more mature approach, and but there's still further scope to improve. Maybe this sort of matches your experience in your business as well. So when it comes to R&D expenditure, interestingly, the largest percentage, 27% of companies, are only allocating 1 to 5% of their R&D expenditure on new technology. However, on average, organizations are allocating up to about 25% of their R&D expenditure on technologies associated with Industry 4. So some of the challenges here, companies with a strong Industry 4 awareness cite the technology complexity as a major challenge. And it is the companies with a weaker understanding actually cite lack of capital for new investment. So how do we improve this? How does one develop the enablers of the leadership, grow skill and capability of staff, and develop their strategy with a digital plan in mind? One effective way is by partnering with the university through translational research. The technology readiness level, or TRL for short, is a commonly used scale where 1 represents the blue sky research and 9 being common industry practice. But how technology gets from 1 to 9 is often a long and arduous journey, particularly through levels 4, 5, and 6 of development and demonstration. This is achieved through applied research, real-world problem solving, process development, concept design, and that sort of thing. And it's a space where universities and businesses must collaborate closely in order to translate the research into real solutions that industries can use. So the FIF, for short for the Facility for Intelligent Fabrication, is a translational research group at UOW. The FIF was set up as a response to the need of industry to not only have access to research capability, to close the gap between state-of-the-art to common industry practice, but also to address the upskilling of the workforce by partnering with TAFE New South Wales. And once that equipment and skills are there, these new processes are certified through the partnership of World Australia. As manufacturing is quickly picking up pace in Australia, particularly as we seek to do things smarter and not harder, one must navigate the new digital solutions that are out there and work out, well, which solutions make sense for their business. So in response to this, the FIF has also established an Industry 4 hub, which is based in the Shoalhaven, which is a regional area of New South Wales, in an effort to support the local businesses that may not be as exposed to the latest technologies as those in the city. So some of the technologies that have made a lot of impact in translational research here at the FIF are around VR, virtual reality and augmented reality, smarter robotics with machine sensing, better understanding of material science, robotic automation, digital twins. And we have a lot of this equipment in our lab available to trial your welding and material handling ideas on your particular product. So when it comes to industrial robots, there are some advantages and disadvantages. Of course, they are flexible, repeatable, and consistent. And actually, the hardware costs themselves are relatively low. However, they are also relatively time-consuming to program, require specific expertise, and are traditionally not very smart. So, for example, when it comes to robotic welding with the Industry 3 approach, this is the way robotics would work, where you've got a welded part that requires heavy fixturing, needs a manual program to be written. This results in a high overall cost and has relatively low flexibility and requires high volume rates. Everything that really goes against the typical Australian manufacturing scene. So it's no wonder that adoption rates have been slow in Australia. However, the Industry 4 approach starts to change the scene considerably. Robots are becoming smarter by connecting digital sensors and software to allow the robot to better understand what's in front of it and allow the computer to make decisions with real-time calibrations. Another enabler is the automatic code generation in the cloud. Going from CAD model to code is a lot like the CAD CAM solutions for CNC machines, but now for 6-axis robots. Even AI and machine learning also play a role through the feedback and is enabling the robot to do the job better each time. This brings flexibility, enables low volumes, and also drives down the cost. So one of the first things with translational research is the opportunity for businesses to be exposed to the state-of-the-art technology. When you engage with the research organization, you start to scope projects that reduce the technical risk of your product or process. You can trial ideas in a non-production environment, taking a scientific approach. Often universities have their own equipment, which means that you can try before you buy and trial a process in the lab. Then once you are convinced the idea has legs and has been de-risked for your product, then you can build a business case and work towards acquiring capability and upskilling staff to drive that equipment. So an example of translational research was with an SME in the regional town of the south coast of New South Wales. They had very little exposure to robotic welding, and they carried out a research program with UAW through an Innovation Connection grant. The FIF, in partnership with this SME, investigated their specific product range and conducted a systematic review of the suitability and feasibility for robotic welding in their manufacturing workshop. The FIF demonstrated the technology of their product and in our lab, and also provided unbiased advice on equipment and processes. Armed with this information, the SME then went on to be successful with receiving further government funding and now have 2 robotic welding cells using their Industry 4 techniques. Another area of research is in additive manufacturing. And this is a video which is not showing, but it's looking for alternative ways to manufacture roadway components using robotic welding. And additive manufacturing like this is still quite low on the readiness level using wire additive arc manufacturing, and is still quite a lot of R&D to get this into common use. I can forward this video on if people are interested. So a response to research organisations moving more towards translational research and the strong support from the Australian government to support these connections, hubs are a popular pathway for businesses to connect with universities. UAW recently set up an Industry 4 hub, which is located in the Shoalhaven region to further Industry 4 capability along the regional New South Wales South Coast. It's another example of translational research pathways servicing multiple sectors such as manufacturing, agribusiness, defence, and even school leavers. UAW's primary pathway connecting businesses to research is called Advantage SME. which helps businesses, small and large, find their ideal research partner and build long-term beneficial relationships and partnerships. So in general, businesses looking to engage with the research sector, URW, you have access to world-class research through simple standard contracts with IP certainty, and most importantly, matched funding. It's always important. So to summarize, each company will have their own requirements and solutions. There's not one technology or solution that will work across the board, and navigating Industry 4.0 can be a daunting task. So I hope I've been able to explain how connecting with universities is a good way for your business to better understand the Industry 4.0 and robotic welding, and tailor your requirements as we seek to advance the sovereign capability of Australia and secure the future of Australian manufacturing. So thank you very much for listening, and yeah.
Thanks, Philip, and thank you to the Facility of Intelligent Fabrication for the continued support. Our next speaker this afternoon is Simon Dawson. Simon is the Director of Industrial Transformation at the IMCRC. Simon is an experienced manufacturing operations executive who has worked in his 35-year career across a range of different industries, including fast-moving consumer goods, industrial, automotive, rail, and medical services. Prior to joining the IMCRC, Simon led the establishment of the Walkinshaw Automotive's new facility in Victoria. Over a 2-year period, he has delivered significant improvements to both the financial and people sides of the business. He holds a manufacturing engineering degree and an MBA, and as well as being a chartered engineer and lean manufacturing expert. Simon, I'll pass over to you.
Thank you very much, Ross. Yeah, so just really quickly, as you say, I come at this from a reasonably broad manufacturing background, and I think there's, to some extent, there's value to being somebody that grew up in a world before all of this, right? So I mean, I'm sort of having to go through the transition like I'm sure many of us are thinking about. So I just want to echo some of those themes. Give me just 2 moments just to get the tech going. There we go. So just really quickly, the CRC model is Cooperative Research Centre. Our role is to help connect industry with universities. You've just heard a little bit about that. We think we've got a fantastic university sector in this country, and obviously when we get into some of these subjects, their capabilities can be extremely helpful. So the CRCs exist to help create that relationship, support funding in that relationship. I kind of don't get too involved in the projects. My job is more to speak to as many manufacturers as I can, just to promote, excite, encourage, get people thinking a bit more about Industry 4 and strengthen our manufacturers, become a bit more innovative as a community, I guess. So really just quickly, just to sort of run around a bit of some of the change dynamic and what we do see and what we don't see in terms of traction. But it's worth just reminding ourselves that I don't think there's any doubt that as a country, we think manufacturing should matter. You've seen what the government's done. It has sort of launched through the MMI, the collaboration streams, and various other initiatives, and I would hope more to come. We've seen a real focus, particularly around these 6 sectors. So we've seen real energy going into how do we strengthen that. The phrase national sovereignty has come right back up again on the dial. Buying Australia has become more dominant. So we think we're actually in a really nice position now to start building and accelerating. But I suppose the question then is, how good are we at the moment, and are we ready for that build? And we heard a little bit of that earlier from Phil about where we are on the Industry 1, 2, 3, 4. Are we ready for? And I heard somebody the other day talking about Industry X.0. Are we ready for that, or are we a bit earlier? Well, I think you have to look at a few stats. So you may have seen this, the economic complexity data. So this is a value of how complex is what we produce and manufacture, and how ubiquitous is it. So if we make something that's very clever, but everybody makes it, we don't get as many points as if we're the only people that make it. And we're about 86th, I think, last time I looked on this graph. So everybody, sorry, I've skipped forward. GDP is declining, but as well as that, economic complexity. So we are now 86th on economic complexity, which really tells us that as a nation, we just haven't kept up with other parts of the world when it's come around to being innovative, driving technology, and putting stuff out into the global market that is leading from our point of view. Now, there are some great examples in the nation, but as a whole, we've got work to do. So we see that we all should be taking advantage of where Industry 4 is and saying, maybe this is my opportunity. So is this the position where we can start to correct some of that? So as a team, our ambition, I guess, is to continue to promote that dynamic that says manufacturing is important, but we've got work to do. We've definitely got work to do. So when we think about Industry 4, I know we've talked on this in a couple of different dimensions. I think there's some real value in just quickly jumping across the range. I believe one of the challenges we have is almost the paradox of choice, because there is so many different ways we can go here. So let's just touch on them really briefly. So obviously we've talked a little bit about Internet of Things, connected devices, becoming intelligent. There's clearly significant ways in which that can change the way you address and contact and talk with the market. That could make a big difference to you. Put yourself in a position where you're able to deliver something, add data through capability, give your customers more than they currently get. There's obviously the other dimension, which is true technology. You know, within the walls of your facility, is Industry 4 that for you? Is it about additive manufacturing or robotics, or is it about real-time data within your facility? So is it about an internal dynamic? Is getting a digital twin with AI on top of it, as Sue talked about, as an ability to make me reassess and become a much tighter supply chain? Is that kind of where my dynamic should? And of course, it could be all of these things. Just will disappear briefly. Is it AI? Again, we've talked a bit about that. So how does that work for me? Augmented reality. Again, I have a bit of a personal view that I only spent a large amount of my time in assembly environments. I think augmented reality, again, is something that's going to hit us hard and be a huge opportunity, and get connected across each of those. So is it an organization that if you have multiple facilities around the country or indeed around the world, do you use augmented reality to service, to train? Do we stop having manuals? Do we move to having augmented reality support? And do we have some projects that are doing exactly that? And across all of those, of course, we have advanced and complex materials and processing. So there are multiple dimensions here of things that are happening that could be your dimension and your tactic. And if you think about where it's going next, and again, I feel like I'm intentionally making this a bit scary. Where it's going next is, and we're already starting to see the language change to this from it being isolated items. So an organization, we have a 3D printer, we have a cobot, we have some IoT, to being how are these things connected? And I include this slide for a couple of reasons. One, because I think it's worth having that mindset of digitalization of the supply chain, real-time integration, people, machine, and things, the way that's going to work is going to impact the future of work. The thing I find quite interesting about this message is I think you could also turn it the other way up. You could have that green arrow going vertically, not down, you know, so it could be the future of work is going to drive that demand. As we recruit people who are digitally native, they've grown up with data around them, they expect instant apps, they expect to be able to communicate instantly, speedily, get the right data. They're used to augmented reality. Then maybe the way people expect to work is going to change. What people expect from their supply chain, what they expect from their product is going to change. So there's kind of a two-way thing. I don't think we should be just thinking about as our technology is going to change the world. You could also argue the world is going to change what we have to do with technology and absolutely influence what is expected from us as an organization. And this is an important dynamic to throw across it as well. I've seen this in a bunch of different ways. I quite like that, you know, if you Google this question, you'll see all sorts of versions of this, but fundamentally saying, think about the rate of adoption of technology that we now have. So again, you see here the landline phone, you see it coming up, you know, it echoes some of the stuff around industry 2 to 3. You know, pretty slow, pretty steady. You know, a bit of a blip there, probably with the depression, that sort of stuff. And then a cell phone, pretty quick. You know, we all know that. So if you're old enough, you remember the person that had a flip phone, and then a couple of years later, maybe you could afford one yourself. It was a really gradual kind of thing. Tablets accelerating more, and I think it's fair for us to assume that most adoption is going to be nigh on vertical going forward. Most things we do, it's going to be in that phase of virtually vertical adoption around the world and globally. So there is no advantage to being in the so-called Western world in that we'll get the technology first. There is no advantage to location, etc., etc. It's literally going to arrive. So AI, I think, is one. It's really important. We talked about that earlier. the capabilities of that, the adoption of that, the way in which that influences things is not going to somehow happen over the next 10 or 15 years. It's going to turn up fast, and augmented reality is going to do the same. So the critical message for me across all of this in terms of what we talk about is accessibility. If I wind back to my career back into the mid-80s, a lot of these technologies were kind of there. We had a robotic cell built that had a conveyance system that read, not barcodes, but read some sensors. It knew the bill of materials, so it intelligently directed things in and out of machining centers. It was kind of there, but it was big, it was expensive, it was probably 3 years planning. Swiss engineers used to fly over, there was cages around, things that had cages around them, so there was lots and lots of things. Whereas now, and we have to think this way, all the technologies we talk about are becoming cheaper. There are ways you can access, start with machine learning, head towards artificial intelligence. Buy 2 sets of HoloLens and start working on some basic augmented reality. These techniques are easy to engage with. Your first step into robots and cobotics could just be, I'm going to buy one and work out how to use it. What is it that we do? Everything's scalable. All these technologies are getting stronger and closer. But as leaders and people in the manufacturing sector, what's critical is we need to make those choices. We need to be thinking about what the choices are. So if I just pull up one particular example, there's a guy called Roger Martin. This is his strategy framework. And I think he's saying something really important here. That absolutely applies to where we are from a manufacturing perspective. And I'm going to pick on that middle row. Strategy is about increasing the odds of success. If you consider that rate of adoption being nigh on vertical, if you consider that there is going to be something new turning up in 3 years' time that we're not ready for, and if you consider that we might feel a little bit behind in some regard, then we need to be increasing our odds of success. We need to be doing things that start us on a journey. I don't believe that manufacturers should be sitting down and working out their 10-year technology plan and stapling it up and saying, right, that's it. I believe manufacturers need to take the first 3 or 4 steps, work out what they are. Increase your odds of success. Put yourself in a position where you are better off and you are learning more and you are stepping forward. And to back that up, Roger Martin also talks about this idea here of, I'll just point to this middle stuff, thinking about what capabilities need to be in place, what management systems are in place. So I think your question is, what is this technology? How do I best use it? But there are questions that go with that. Cybersecurity is obviously a really critical question. If you are going downstream into data, if you are going down the AI path, if you're going down a bunch of these dimensions, then you must have a capability to think about cybersecurity. We absolutely expect that. What management systems are controlled, what control mechanisms are required, but how will you win? How does this help you win? So I raise these as very MBA style subjects, but I think it's important that as we go through this, we're thinking about the fact that this isn't simply about picking a toy and putting it in the corner of the facility. This is about thinking about when do we invest, what do we invest in, why do we invest in? And McKinsey, another competitor, but McKinsey talk about top trends in tech, and I think they're a really, really good article they put out during the year. And they talk in there about one critical discussion is when to invest what in and why. So we need to be thinking about what is the scale of the impact. Is this technology going to take over my part of the world? How rapidly accelerating is this? Is it miles off or is it now? If it's now, can I afford to not be part of this? Do I need to get my foot in the door? And am I ready for it? Do I have those skill sets? So when I talk about those choices and about those technologies, what I'm saying is you need to be thinking about, well, what's out there? Where's it going? Where's it coming? And are we ready to move? Am I ready? Is my organization ready to think about that? Quick example, Swarm Farm, just to relate to where we were. So if we set up as a bunch of manufacturers sat in a room and decided to establish a new factory for making dispensers of pesticides, etc., we'd get welders, fitters, electricians, a painter, quality control, dispatch, goods inwards, and you could pretty much write down who you'd need. Having gone into the IoT world and having started to think more about app development, they are an organization that's turned that dynamic. Their future of work is now driving what they're thinking about. And having taken the steps, a great example of, once you've taken that first choice of enabling the device, they now have created their potential, opened up their doors of possibilities. Once you are connected, all of a sudden you can go from just being able to remote control to having absolute brilliant GPS data year on year that says, what did you spray, where and why? Do you put sensors on the wheels that can then sense that this bit of ground's a bit muddier than that bit of ground? What else can you do? So once you've started, they really have opened up a whole bunch of doors in terms of possibilities. I'll skip these. We talked about those briefly earlier. So I just want to sort of close on this really, because I just think this is really a critical dynamic here when we talk about what's happening with Industry 4. This has got a Gleichert talks about change happens when the products of dissatisfaction with current state, clear vision of a future, and practical first steps is greater than emotional pain. And I want to narrow in on that practical first steps. Phil mentioned it earlier, the stats I just skipped over said the same, that the awareness of Industry 4 is great, 60–70%, pretty good awareness. But actually what we find is that people doing something and talking about it, or actually going through the effort of creating that strategy, is not as strong as it should be. There is plenty of opportunity for organisations to move forward. My experience, having worked with a bunch of organisations delivering our tool Future Map, is that those first steps seem to be a key barrier. And I think that's where we have to think about, how do we unlock that potential? If first steps are critical, understanding what the first steps is critical to us being able to build some momentum, then absolutely that's where the university network is great, for example, at helping us with confidence. So my closing message, I think, is we have an accelerating dynamic. We have technologies that are going to be wondrous. We have a workforce that's going to want you to do it. But we have a little bit of inertia. There is no doubt about that. So please try and avoid being lost in the paradox of choice, because there's so many things out there. And let's try and make sure we think about, well, if I make a step, if I make my first step, if I understand and think about those first few steps, I have given myself more options beyond that. If I spend my time trying to work out the complete solution, I suspect we'll find it too hard because of that, the challenge of the complexity. So with that, I'll close and hand back to Ross. Hopefully you got a sense of my perspective here. I believe most of what we have to do is think about our change dynamic, and find the partners, find the universities, the consulting teams, the facilitators that can help me think about my path. How do I open my doors of possibility? Because you've heard earlier, you heard from Sue on AI, for example. There's fantastic stuff out there, but you can't possibly do it all. But you need to make sure you don't do nothing.
Thanks a lot, Simon. That was really, really interesting, and hopefully we can get the IMCRC to do some in-person events in the next calendar year, obviously with the world unlocking. Our next and final speaker this afternoon, followed obviously by the Q&A, is Jessica Olivier. Jess is the National R&D Lead for RSM and Head of Manufacturing. Jess has over 15.5 years experience assisting startups, small to medium-sized businesses and multinational companies to claim their R&D tax incentive. Jess works with companies to prepare and lodge their R&D claims from start to finish to provide a seamless process, defensible and robust claim. Jess has worked with many varied companies across a diverse range of industries, including manufacturing, technology, energy resources, construction and engineering. And I'll pass it on to Jess. Thanks a lot, Jess.
Thanks, Ross, and thanks to Simon, Phil and Sue. That's all been extremely relevant to this sort of final section on the R&D programme. I think what's been key for me is listening to you all talk about how robotics, automation, AI is playing such a huge part of manufacturing. So I guess we're moving away from that traditional production of a widget to how we're going to automate processes and use clever technology to assist our processes. So with that, I'll talk about the R&D tax incentive and provide an overview of some of the updates of what's been happening in this space in the last sort of year or so. So I'll talk about the actual programme itself and recent changes to the programme. I'll focus a little bit on some areas of regulatory scrutiny, talk about how to identify eligible activities and expenses within your manufacturing business. And then lastly, I'll touch on potential industry-related government grants. So for those of you who may not be aware, I know some people on this call already claim the R&D tax incentive. Some are probably wondering how you might benefit. It's a broad-based entitlement program. So that means it's a self-assessment program. If you self-assess that you're undertaking eligible R&D activities, then you're entitled to make make a claim every year. And currently the program's accessed by 12 to 15,000 Australian companies every year. So this program supports the development of new or improved technologies, products, processes, etc., or the acquisition of new knowledge generally. So going back to what we've been talking about, that's implementing AI into your manufacturing process, or using new robotics to make a process much smarter, quicker, easier, and not knowing how the outcome is going to be achieved. As I've mentioned, as Ross alluded to, it's not restricted to any industry or sector. I've worked with clients across such a wide range of sectors, and obviously what I'm seeing now is a lot of that overlay for technology being embedded into manufacturing. The programme itself is administered by two government bodies, AusIndustry, who assess the technical eligibility of R&D claims, and the ATO, who assess the eligibility of the relevant costs claimed. And from the budget 2020, there was a refresher of, that was the budget back in October last year, the COVID budget, I believe. There was a refresher of the R&D tax incentive from 1 July 2021. And generally, there's been an increase in benefits for all companies, which I'll talk through. And as always, there's a few statistics there which people always enjoy. For the 2020 year, there was just under 12,400 claimants, and with a value of 12.7 billion of R&D tax offsets claimed. So I mentioned changes to the program. So if you're a base rate entity and your turnover is under 20 million Australian dollars in the year, you can see the benefit that's actually been increased by the government further to the COVID budget, as I mentioned. So back in 2019-20 financial year, the corporate tax rate for companies of this size was 27.5%. The R&D tax rate for these companies was 43.5%. This led to a 16% permanent R&D benefit. But also, as many of you will be aware, if you're in that position where you've actually got tax losses or you're in a startup phase, you're not actually making money, so you can't apply the offset to tax payable, then the government cashes out this full 43.5 cents in the dollar per dollar spent, so which is pretty generous. Then as the tax rates started to fall in 2020, 2021 to 26%, you'll see that the benefit increased. The permanent benefit became 17.5 cents in the dollar. So with the credit remaining the same at 43.5%. And then post the federal budget changes, you'll see for this current financial year ending 30 June 2020, the government's actually changed the benefit to decouple it. I suppose if you can see that as the benefit, the corporate tax rates have decreased, the R&D benefit has gone up, which I don't think was an intention of the government. So to avoid any interplay with the corporate tax rate changes, they've basically now fixed the R&D benefit rate at 18.5 cents above the prevailing corporate tax rate. This still provides a 43.5%, as you'll see, refundable portion for companies in a tax loss position. So it's pretty good news for companies, and particularly good news for those small businesses or manufacturing businesses that might be paying tax, because you're now entitled to this 18.5 cents per dollar. It's probably the highest it's been for a long time. If your company's $20 million revenue or greater, as you may also be aware, there was a 38.5% non-refundable tax offset available. Here, the permanent benefit ranged between 8.5% to 12.5%, depending on whether the business was paying tax at 27.5% or 30%. Unfortunately, for companies over 20 million, if you're in a tax loss position, you don't get to cash out the R&D tax incentive. However, you get to carry it forward on to later years when you start to pay tax, and then you can offset it against future tax income. Again, we've talked about this a little bit today, and we talked about R&D intensity during, I think, Phil's presentation. What the government's doing from 1 July this year to sort of incentivise companies to do R&D is fixing this benefit onto an R&D intensity rate. So for companies who are spending 2% of their total expenses on eligible R&D expenditure, they will get an 8.5% benefit, which is same as the rate now, based on the 38.5% tax credit and 30% tax rate. But what they're doing to incentivize companies to claim more R&D is when you go above that 2% rate, you'll attract a much higher benefit. So I'll just move myself away there, of 16.5 cents per dollar. So really, that's really quite generous for large entities, and the biggest we've seen in a long time. Obviously, it's difficult to forecast the exact permanent benefit, as this will depend on the R&D intensity, but you can look at what you've claimed previously, do a bit of modelling, and generally this new structure will provide a higher benefit than the current programme. Also, just note that for December year-end companies, this will come into force from 1 January next year. Just a quick refresher of how you claim. What's the process? As I've sort of alluded to, it's an annual process, but it's a retrospective claim. So you get 10 months from your financial year-end to lodge a claim. So for 30 June 2021 year-end, you have until 30 April next year to lodge that form with Oz Industry, register your R&D activities. Once you've registered your R&D activities, you can then claim your R&D expenses in the company income tax return. So often companies do it earlier in line with the due date for their company income tax return, but there isn't an issue if you haven't managed to do your claim or you didn't know about the program and you do want to look into a potential opportunity. You can quite easily amend your income tax return for an R&D claim lodged during that year. So the critical part is to register the R&D activities by 30 April of the following year, and then amend then lodge your tax return with the eligible expenses claimed. And then just be aware, and I'm sure you've heard, that you do need to have documentation for technical and financial support, and evidence what you've been doing and how it meets the R&D eligibility criteria. Just moving on to some areas of focus, because again, the R&D industry has been in the media in the last sort of few years, particularly around software and mining, which is relevant, as I said, where software has an interplay or technology has an interplay into manufacturing. As you're probably aware, there was a number of high-profile sort of reports to the media around Airtasker, for example. Their claims were reviewed by Oz Industry and the ATO and eventually came to a settlement, but they were under a lot of scrutiny. The big banks were under scrutiny for very large technology claims, and there was various headlines around other small tech firms having to pay back millions of R&D after not claiming it, well, not necessarily claiming what are eligible R&D activities, which I'll chat through in a moment. But post that 2016-2018 period, we have seen sort of a more favourable change in the landscape. There was the landmark Morton tax case, which was the first full federal court win for the R&D tax incentive claimant post the commencement of this programme, which was actually 10 years ago this year. The Small Business Ombudsman, led by Kate Carnell in Canberra, at the end of 2019, did a report into the behaviour of the authorities, I suppose, in the administration of the programme, and came out with a suite of 24 reforms for the programme to improve. And then there were a couple of other cases in the AAT. There were some other headlines around Northern Minerals, and basically they sort of all led to a more positive change in how the programme is being administered. So generally, and with this and the COVID announcements to increases in the R&D programme, it's generally a much more favourable landscape. Part of the changes implemented due to this scrutiny on the programme. You can see here there's a new integrity framework which has been in place for around the last 18 months. So when you lodge a claim with Oz Industry and lodge your application form, they do look at every single claim that's lodged now, and they basically rate them on that traffic light system you can see there based on the detail on the form. So, if you've really clearly and concisely relayed what the R&D is that you're doing and how it meets the eligibility criteria, you'll likely get a green, categorised as getting it right, receive your registration letter, which is the number you get that goes in your income tax return. If they read it and they're not 100% sure on how you're meeting the criteria, but they can see you're trying to make an effort and can see there could be eligible R&D there, you might get some further correspondence. You'll still get your registration letter with the number into lodging the income tax return, but you might get you might have an education visit where someone from Oz Industry will come along and visit your premises, sit down with you and talk about your R&D and provide further written guidance on how to better support your claim. And if they believe that you haven't really articulated the R&D that you're doing and that they're concerned that your R&D doesn't comply, then you receive further correspondence from Oz Industry, and they then might commence to undertake a statutory assessment into your claim and have a meeting to understand what your R&D eligibility is, discuss their issues with your claim, and see if they can come to a conclusion on that claim. So you've got kind of a traffic light system in there, I suppose. Again, for another new sort of change for this year or new mark on the landscape, there's a new R&D claim process. So for all R&D applications lodged from 1 July this year, there's a new online portal which you access via MyGov. For this, for an R&D tax agent to assist you, you need to give them authorization to access the online portal on your behalf. This portal is used to request lodgement extensions, apply for overseas advanced findings, etc. It has introduced hard character limits, so these forms on here are a lot shorter than the previous smart form PDF that you might have been used to, and can no longer, unfortunately, add attachments, photographs, diagrams, etc., which was pretty handy on the prior forms. They do require you to complete a checklist of documentation maintained to support the eligibility of the claims that you're doing, although you don't have to provide this up front, you do have to state what you have. There's also a renewed focus on describing the existing sources of information and knowledge that you consulted in order to prove that you needed to do R&D, which I'll talk about again in terms of the criteria. Oh, sorry. So just going back there to what is an eligible core R&D activity. So when you go to register your R&D, it's not a project level, but it's actually looking within your projects that you're undertaking or the initiatives that you're doing to understand what is an eligible core R&D activity, and you need at least one of these to form your claim. It has to be an experimental activity where the outcome cannot be known or determined in advance based on current knowledge or experience in that field. So from the basis of a competent professional in the field, an engineer or software engineer. The experimental part alludes to testing or trialing required to resolve technical uncertainty and that unknown outcome. The activity is conducted for the purpose of generating new knowledge. And as I mentioned previously, this is in the form of new or improved products, processes, services, devices, etc., which you find in manufacturing. And it can only be determined by a systematic progression of work that is based on the principles of established science and proceeds from a hypothesis through to experiments or testing, through to observations and evaluations, and through to logical conclusions. And I say this slide really rang true with the comments that Simon made previously around your strategy, having hypotheses that are creative and scientific, and also, increasing your odds of success by undertaking R&D. So once you've established a core R&D activity undertaken in the year or one that you might undertake in a future period, you can also claim your supporting activity. There's also a list of excluded activities here which cannot be core but can be supporting, but just in the interest of time I'll skip through that and I can provide these slides afterwards. But basically a supporting activity is one that's directly related to that core experimental activity that I mentioned. So it might be in the case of background research that you're doing, what's already out there, patent searches that you did to see what was available in the market, your initial design phase, the formulation of the hypothesis that you plan to test prior to doing the experiments, the project management, the data collection, the consultation with experts, etc., and developing the prototypes to be tested. So all of these types of things, whilst not experimental in themselves, are supporting R&D activities and attract the same financial benefit. One thing just to note there is that also the R&D Tax Incentive website prior to the launch of the portal was also updated with new guidance in May this year. It includes really good fact sheets, animated podcasts, videos, and that sort of thing to really assist with how you might make a claim on what is and isn't eligible. And here, just to give you a sort of taste of what the types of things that we've seen claimed in the manufacturing industry, but also across different sectors, you'll see here there's a number of projects within farming. We've seen new genetic variants develop, new seed types. We've seen new farming methodologies to improve yields, just like Swarm Farm that you saw, companies like Drone Shield, that type of thing. We see equipment innovations in new conveyor systems in mining, in new spreader designs and spraying equipment in agriculture. We see new construction processes and products, so new concrete mixes in construction and engineering, again, that overlap with the manufacturing sector. We see materials, new materials such as in shoes, cricket padding, safety helmets, packaging materials, transportation systems and seating, that kind of thing. And I suppose one of the key ones we've been talking about today is the potential for software and IT related activities to be claimed as part of improvements to your processes. Again, we'd be looking at specific experimental activities that involve new software, logic, algorithms, AI, augmented and virtual reality, that sort of thing. And then you see around new consumer products, so new cosmetics, toothpaste, mouthwash, medical devices, and also in the food and beverage sector. Again, the key question we often get is what types of costs can we include? Well, the key driver for claims is typically time spent on the R&D activities through the wages and salaries we can claim. We see items directly related to the activities like testing costs, software costs, development of prototypes, equipment for testing. We see contract expenditure in the form of subcontractors, specialists involved, consultants. Depreciation on plant and equipment used in R&D activities can also be claimed, and this can really be quite generous, which I'll talk about shortly. You can then include a number of other direct expenses like travel, training and conferences, and then we look at an allocation of overheads as well based on authority guidance. So as you can see, the claim really can go up quite big, and obviously just to be aware there are areas of scrutiny for the ATO when they look at the claims, and they can be in terms of overheads or looking at overseas costs which can't typically be claimed. So it's important that you get the right advice in terms of what you can claim. And so just the last couple of slides here, just to touch on other sort of opportunities within the R&D programme. The COVID budget in 2020 did allow for some generous rules around claiming depreciating assets under the R&D tax incentive due to the temporary full expensing measures. That was part of the budget this year, 2021, but also under 2020, we saw the instant asset write-offs and the use of accelerated depreciation. So not only claiming those assets in full that you purchased under these both budget measures, you could, where they're used in R&D, you could pick up that accelerated amount also. There are also companies which will finance your refundable R&D claim during the year. So, you know, if you're entitled to a refundable R&D tax offset, but you can't, or you need cash and it's hard to wait until year end to put your claim in and await the ATO refund, there are a number of companies out there who will finance the R&D that you spend during the year, which provides sort of much needed capital cash flow during the financial year. So just to touch on in my last slide, as was sort of mentioned earlier by some of the presenters, the government's been really focused on manufacturing in the last 12 to 18 months, or particularly since COVID and the bringing back some of the manufacturing to Australia. There's a number of other grant programs available outside of the R&D tax incentive. There's accelerating commercialisation, as you can see there, up to 50% of match funding to up to $1 million. There's the export market development grant, which is retrospective for last financial year, but they're doing on a, I suppose, real-time basis this year. You can claim in the year for financial year 30 June 2022. There's some extremely large modular manufacturing grants out under the Modern Manufacturing Initiative, and there's 3 streams under those. One thing to note there is that the government wants to see large manufacturing projects being shovel ready. The project's ready to progress, just need funding, and you can apply for these grants. And there's also some early stage innovation company incentives available to startups. What I would note there is that these, as some of you on this call may be aware of, these grants can be really hard to access and take a lot of work. Obviously, it's free money, so the government does judge you again on that competitive merit-based criteria, but it's certainly something to look at because the amount of funding's extremely large. It's just to be aware that a lot of time and resources needs to go into filling out the detailed grant applications. So just to finish, my details are there, but I just guess what I wanted to reiterate was how this R&D tax program does really overlay all the advances in robotics, in artificial intelligence, all the future of manufacturing that Simon talked about. So it's really critical that as part of your strategy, you consider the funding that you can get from the government, both under federal and state levels. With that, I'll wrap up a little bit over time, I think, and we've got about 5 or 10 minutes for questions. So thank you, everybody.
Thanks, Jess. And a great kind of segue there into, we've got a question for each of the panelists, just to quickly run through before we finish. The first one is for Sue. Sue, what do you think Australia needs to do to get the most out of robotics and AI in manufacturing?
Well, it's a sad reality that Australia actually doesn't manufacture any industrial robots, which are the main type of robots that are used in manufacturing. So what Australia is really good at is doing service robots, which we've seen some examples of. For example, Swarm Farm's robot, or I like to call it outdoor AI. We're really good at developing those. And I think what I would like to see in the future is that we have some of our own sovereign capability so that we can be supplying into manufacturers with our own industrial robots. And I think that with developments like the Haddington Dynamics Dexter arm, I think that could be a possibility. So we're not up against those very high asset, capital intensive robots. And I think increasingly as we see robots become more collaborative, again, that's probably playing to Australia's strengths in sovereign capability. But, at the moment, I think it's a sad reality that, for most manufacturers, you'll be buying robots that are from other countries. And it would be great to see a future in Australia where you could be buying those robots from here.
That's great, Sue, and thanks for that. It was really detailed. Phil, so we've had a comment here around, it's often thought that engaging with the universities is difficult. What do you think the best way to start that relationship is?
Thanks, thanks, Ross. I guess traditionally, who do you contact within the university might seem like a daunting task. At the University of Wollongong, we've set up a group. I mentioned it in the PowerPoint slide, Advantage SME. They're part of our Innovation Commercial Research Unit, and they're a fantastic gateway for industry to contact as initial point of contact, and they can get you in contact with the right researchers within the university sector. Of course, when it comes to manufacturing and fabrication, there's forums like this, forums like what Simon spoke about with the IMCRC. There's lots of forums in which companies can make contact with the university, and particularly at URW, we try to make that process as seamless as possible. standardizing contracts, simple IP control and that sort of thing. So as more and more traction goes in through, particularly as the government's push for getting businesses to collaborate with universities in their R&D, we at UOW at least trying to make that as simple as process as possible. So yeah, reach out to myself or to Advantage SME as well at UOW, and that's a nice way to do that.
Thanks, Phil. And Simon, what is the single thing you'd suggest manufacturers do? And just to focus a little bit on, we're getting a lot of feedback from clients around cyber and cybersecurity and things like that. What's your main piece of advice as we move hopefully into that 4.0 world? And you're on mute, Simon, apologies.
Try again. Yeah, I was reflecting on some of the stats we had the other day. So yes, we see a lot of people understand what's going on, but not talking about it enough. And a stat that goes with that is, we see only about 30% of people saying that they understand the competitive advantage. So I think for many, the first question is, have you had that conversation that understands how, of all those technologies, what's happening in your space, what's happening with what you're doing, and how does that going to direct you from a competitive advantage point of view? If I'm an SME, I've got my eye on cash flow, I've got my eye on safety, I've got my eye on quality, I've got my eye on clients, customers, sales. We have to have a conversation that says, I understand the competitive advantage of this, otherwise it never gets on the to-do list. So my instinct is that people need to have had that conversation. And I know the university teams are great at helping with that. People like the AI Hub good at helping with what are case studies or examples of that. So that conversation, I think, is critical, because that then leads you to, in the direction, work out what the direction is, and then you can say, what are my capabilities? So if your priority is going to be additive manufacturing, then clearly cybersecurity is not a capability that's going to be as critical to you as if it's downstream AI through a supply chain engaging through social media. But you've got to work out what's in it for you, right? If there's no value to you, you're not going to do it. But if you don't do it, somebody else will. So you need to be in that. For me, the biggest thing I see is it's not being talked about enough. The opportunities aren't being talked about enough. And I think that's because people haven't had an open conversation about where will I find value.
Thanks, Simon. And I think that's a nice way to kind of wrap up this afternoon's webinar. So on behalf of RSM and we just want to take the time to thank you all for taking your time to engage with obviously everyone who has logged into the Zoom today, but then also for those people who kind of tend to go and watch. For everyone who's attended and for those who signed up, we will distribute the recording and some collateral around. There was mention of some videos and where you can watch them and everyone's contact details. And on that note, I'd like to hopefully wish everyone a good afternoon, and we're hoping to get back into some more in-person events in the new year. But on behalf of everyone, thank you for taking your time, and see you all soon.
Thank you all.
Cheers.
Thank you, everyone. Thanks.